an invitation. Make this your stage, or at least, like be as open and forthcoming with your comments as you'd like it to be. You're all here for a reason, so this should be as much of a two-way conversation as you'd like it to be. Okay, so feel free to take a seat. Feel free to just chime in if you'd like, or gradually raise your hand if that's your preferred way to do so. And yeah, really happy to have the second round of this. Thanks for bearing with us, and very, very, very excited to be joined by Dean and Mark from Agoric. And first of all, thank you guys so much, both of you, for hosting us here. I have no idea how you get any work done in this place. And Christine and I are already scheming on just moving our Foresight operations here. So good luck. Good luck. Yeah, Dean has been, I guess, noting that Mark is taking a lot of time on the book.
No.
So once we move in here, I'm not sure how.
I see.
So thanks for showing us this place. No, but in seriousness, thank you so much to both of you. You've been tremendously inspiring to much of the work that Foresight has been doing. I sometimes think about, I guess a generator function of, we tackle many technologies. We tackle biotech, nanotech, and so forth. But I think really the kind of agoric way of thinking about cooperation and of trying to make it happen in a decentralized way is such a multiplying function for many of the things that Foresight is trying to do in terms of technological progress in a way where it's going well. So you've been tremendously inspiring to much of our thinking and much, since I've been around, definitely, and I know much more before because you've been around for much longer than I have been with Foresight. So I guess just a big thank you to all of the really ground laying conceptual work, and maybe that's a good place to start, really. So, I guess it's fair to say that you've been working on smart contracts and crypto commerce much long before blockchain was even a thing, right? So maybe just pick us up with the history. How have you started to work on this collaboratively, and how did Agoric came to fruition through your really early work?
I don't think we have enough time to go all the way back to
Mark is
Mark smuggling the RSA algorithms out to, but so
I've gone public with that. I waited 40 years.
You did it.
No, I waited 40 years, but I went public with that story. It's in the Reason Cypherpunk documentary, and it's in my Epicenter interview. I don't need to go into it.
that's right.
Statute of limitations is passed anyway.
Of course. That's why I waited 40 years. I don't know that there's actually a statute of limitations for that kind of thing, but I just figured nobody's going to come after me.
So Markham and I met at Xerox PARC doing research in large-scale distributed system programming language for secure distributed systems. And that was a lot of the, precursor ideas. We then met Norm Hardy, who brought in how to actually think about security. And sort of together, the three of us and a few others took Norm's operating system ideas into how to do it in a programming language. And that's been a theme kind of going forward for, now literally decades. But out of PARC, so I was at PARC, I was a student. Mark was involved in Xanadu, the hypertext project, for years before that, coming out of Michigan. And Xanadu started up, and he brought me. The reason why that's important is our sister company, Amex, which Chip ran in engineering for, was doing this funky thing where it was a service that would allow third parties to cooperate, where the relationship was enforced by the service, the brainchild of Phil Salen and others. And they were doing it in a way that ran into stuff that I had learned at Stanford. I was like, no, that's not going to work. And then they tried it and it didn't work for all the reasons I thought it wasn't going to work. And so Randy Farmer and I went through and dug through the contract and redid it a different way. And that was the product that they rolled out, and it worked. And it was only later that the term smart contract, that Nick coined the term smart contract. And we could point back at Amex and go, yep, that is one. And here's the interesting properties about it. And here's why we should do more of it, and we should do more of it for all the reasons that Phil did it in the first place, which is software helping more people to be able to cooperate. My simple characterization of that now is software helping more strangers to cooperate, right? So if you can get more strangers able to cooperate, you get more, you get more cooperation, you get a more cooperative world. And that was how we sort of got started on some of this.
Yeah, I'll say that was, I'm going to paint that as the Amex is one of three threads that came together into the modern sense of smart contracting, modern being mid 90s. So this was all smart vision of smart contracting well before the invention of blockchain. At Park, while I was at Park and Eric Drexler was at MIT, we co-authored the Agoric Open Systems papers. Those are the papers that the company itself is named after. And those came out in 1988, and they paint a vision of what we would now project as automated smart contracts. We did not have the term, but we also didn't have the full vision. The part that we had was we were looking at human institutions. We're very institutionalist in our view of looking at society and economics, and being inspired by them and realizing that in the computer system, we can create in a distributed, secure, cryptographic computer fabric auctions and derivative instruments, and on and on and on. We reconceived a lot of things in terms of market mechanisms, like doing a processor scheduling by auctioning off the next time slice of the processor, which Agoric is now doing something similar on our blockchain. So that was a vision of what we would today call permissionless, decentralized, cryptographic computing with integrated market incentives. But all of the smart contracts were there inside computation. They were used by computation for the purpose of organizing computation. Dean already mentioned the Amex thing, which was very much smart contracts dealing with things that are directly significant to humans. Humans engaged with the contracts to deal with assets that are significant to other humans and to deal with each other. And then Nick Szabo, he had a lot of contributions, but I'll focus on sort of bringing a much deeper cypherpunk. We were all cypherpunks, but a much deeper cypherpunk perspective to the foundations of smart contracting. And he kept trying to explain a particular thing to me that I kept not understanding. And then when I finally saw Ethereum years later, it hit me, oh, that's what Nick was trying to explain to me. So the notion of, so there's two organizing principles. I don't know how there's two organizing.
I want to inject something here.
Okay.
Because he was trying to explain those things. I do want to point out that many of those conversations and many of those explanations were in the back offices at the Foresight office in Los Altos. So a lot of, just like open source term was coined by Chris, at the Foresight stuff, a lot of these terms came out at discussions
before we moved here.
Yeah, before you moved to this house. That's right. That's right. That's right.
So big ones. So I think it's in terms of abstract properties of cooperative systems, which is I think that's important to think about when we project into the future and trying to create good futures in which much of the cognition is not human. Is this ability to figure out what are the characteristics of problem-solving architectures that where you can make similar statements across human architectures and across software systems. Yeah.
I want to say, by the time we were at Sunrise, which is not much later than the Agoric Open Systems papers, we were definitely talking about it in terms of programs providing services to humans and contracting with other programs to make that possible.
Yes, absolutely. And Nick was already a significant influence on us. Nick actually, you probably remember this, worked for us for a time at Agoric.
Yeah.
Well, first I want to say, if you want more info on the whole Amex story and how that may have been smart contracts, but also split contracts as a way, or like how I think Mark termed it, but like as a way to even have some human arbitration in smart contracts, then we have a recording on that in the Intelligent Cooperation group in there. And then also another really, really good talk is Computer Security is the Future of Law, where you and Nick have it out at an expo conference long time ago. Anyway, there's lots of really good references that we don't need to get into now.
Yes.
I think, porting us from the good old days into the current state, right? So what changed, since then? And like, what are the types of technologies that you're currently building? Like from your website, I can tell there's composability, then there's the familiarity with JavaScript, and then there's a big security aspect. So can you tell us a little bit like what's...
Actually, can I do one more thing about the foundry?
Do it.
Because there was a panel that I'm not sure whether you put it together or Chris put it together on the applicability in blockchain. So the reason why that's important
With Zuko and Arthur and...
So that Zuko Wilcox, Arthur Brightman of Tezos, so Zuko of Zcash, Arthur Brightman of Tezos, Brian Warner, who had just finished or participated in the security review of Ethereum, Mark Miller, who he was working at some small company over the hill, and maybe a few others.
Well, in particular, I just want to mention Jorge Lopez.
Yes, that's right. Of Gravity, yeah.
Jorge Lopez had a critical part to play in the history here because we had evolved one smart contracting paradigm before blockchain. Then blockchain happened, and I was just puzzled by it because it seemed like such a different paradigm. And I kept trying to figure out, how does our paradigm and this paradigm, how can we bring the best of both together? Because they're getting so many things wrong, but they have some things that are brilliantly right that we never thought of. And I couldn't figure it out. And then Jorge Lopez was a person involved in the world of blockchain who had read my papers and had a very clear vision of how these things fit together and found me and explained it. And that's really, in some sense, the enabling insight that enabled Agoric to happen. And it's basically that they're not competing paradigms for solving the same problems. They're actually solving problems at a very different level. So our technology simply sits on top of the blockchain technology. We think of blockchains as just credible computers. And when you look at it in this way, they compose together directly and sort of obviously once you have the insight. So I really want to thank Jorge for the insight.
Good. Yeah. And at the time, there had been these giant security breaches. And so the idea of actually having some approach to security that might solve these problems was really at the top of mind for a lot of people. And so that panel came together. It happened to come together right in the middle of Tezos' fundraise. So while Arthur Brightman is at the panel talking, the value of his company probably went up by $20 million, right? It was a very, very crazy time. But the result of that panel was, oh yeah, there's something here. And so, Markham, Zuko, they brought in others, brought me in, and eventually that ended up starting to work. So that panel that Foresight helped put on is directly responsible for us kind of being here in some important sense.
Well, thanks. So now tell us, what are we responsible for?
Okay. So what, I'll skip to what we're doing. So Agoric is building a layer 1 blockchain, so an independent sovereign blockchain. We are leveraging consensus technology that is built by, the original proof of stake chain, which is Cosmos. So we're using Cosmos ecosystems, Tendermint consensus technology, which is nice. It's battle tested. And that's not the part where our big innovations are. So it's great to be working with sort of this extended community. And the real magic here is being able to write smart contracts in a hardened version of JavaScript. So that means, so most of people think of, if they think about blockchain smart contracts, it's on Ethereum, which has a programming language called Solidity, which is okay, but it's one of those things where if you designed a language for people to be able to start doing small examples with, it might look like that. But to do large systems, yeah, there's some security hazards that are kind of insurmountable. That are sort of,
using JavaScript already?
How many programmers here, and then how many do JavaScript?
I'll go back in time and tell the designers of all the great programming languages of the 60s that in 2021, the most common languages in use will be JavaScript and PHP. And let them scream.
It's not clear that they have surpassed Excel macros yet. So it could always be worse. So being able to write smart contracts in JavaScript means that instead of there being at best 10,000 programmers that can do this stuff, there's 10 million programmers that can understand this stuff. and we can approach, programmers that are outside of crypto, and instead of sort of everyone arguing over the same really expensive programmer, we can now make it available to a much broader range of people, of developers sort of worldwide. If we're going to have a big impact on how people coordinate, on how people do things, you got to be able to enable many more developers to do this independently without having to go to a small priesthood of programmers.
Okay, so that's the familiarity. Get it. I like it. And what's the security aspect? Because, we do all know that Mark has a very big, not vulnerability in terms of securities, but he really, what is the big security cell that you also mentioned,
Sure.
It's really what drew Zuko and the others in at the beginning. Because I think it is something that is currently still undervalued somewhat, but that will become really important the longer we want to build security.
So,
Can I just add one more thing before you move on? You're speaking to how much easier it is to hire these programmers, but the whole point of smart contracts is that other people can trust them. And so it's extremely valuable that you have the simplest possible programming language for other people to be able to inspect and be sure
Absolutely.
the smart contract is doing.
That's right. Yep.
Wait, man, you have no. Okay, hold on a second. There's so first of all, Greg, you know that we're in the object capability paradigm. So independent of the particular messy details of a programming language, there's the essential question to ask about a secure framework is what is the semantics of the boundary between mutually suspicious entities, and what the semantics are of the computational primitive within an entity. Sure, that's just sort of the normal computer science, language design, instruction set design, whatever. The semantics of the means by which these entities interact with mutually suspicious entities interact with each other, that's the important thing to get right. And what we've done, which I know Greg is also a fan of, is we have projected the object capability paradigm very cleanly into JavaScript. And I've been on the JavaScript Standards Committee, TC39,
Stickers out there.
since 2007, doing this, not thinking I was going to leave Google to form a company to do this, doing this as a representative of Google on the Standards Committee. We published a paper explaining how engineering JavaScript so that it was good for smart contracts was also making it a better programming language. And every step that we did in evolving the JavaScript standard was sold to the rest of the committee correctly because of its general software engineering benefits. And this paper explains why we should expect supporting smart contracts better to generally lead to better programming language design.
Good. Do you feel like you've covered the security angle with that, or haven't you close?
We barely touched.
Yeah. So
I have a couple of very simple, characterizations of how of JavaScript and securing it. Right. There's several scripting languages like JavaScript, Python, PHP, other things. JavaScript starts out very malleable. And so a lot of the insecurity, partly it's historical, partly it's you can change what it means to iterate an array. So in addition to iterating the array, you will copy it and send it to another country. Or in addition to printing out some log message at the console, you'll search for the private key file and send it somewhere else, right? That's not great, right? But because of the things that have been deliberately driven into the language, we now have the ability to lock it down. Right. And we crossed that threshold. It was like, 2018, we put the company together and we were thinking about all the work we were going to have to do to get stuff into the JavaScript standards. And because of some of the work that we were doing with other people in the JavaScript standards committee, in particular, I think Salesforce, the guys at Salesforce, right? That we realized that all the pieces we needed were there. And so we could actually lock down JavaScript. So now instead of building on quicksand, you're building on concrete. So what it means is now with this lockdown JavaScript, this hardened JavaScript, there's no mutable shared state. And there's no ability to change the primordials. You can't change array iteration to do something unexpected. So now suddenly, one JavaScript computation running over here can't share state, can't leak secrets, can't hammer on some other disconnected JavaScript. And that transition, that is the essence of what we needed to be able to apply all of the security learnings from Scheme and from Norm Hardy and Kikos and all of those things to do the OCAP model in JavaScript. And we've done that model in multiple programming languages. You know, we did it on top of C++, we did it to Tickle, we did it to Java, we did it to C#, we did it to OCaml. We've done the same kind of approach in all these systems, and it turns out that it's actually easier to do it in JavaScript than in any of those other programming languages. It's sort of, you know, crazy on the face of it, but it's sort of an accident of history.
And I think it's
what's remarkable about your list is that every single one of them are sequential, and the big game changer is the shift from sequential to concurrent.
Let me just a bit of the history here. Coming out of Dean did a programming language called Joule that is as highly concurrent as what you have in mind. It's sort of pi calculus or actors scale, fine-grained concurrency. And that was also a distributed, decentralized object capability language suitable for smart contracts. And that was the starting point of a lot of this evolution. But the problem is that even very smart programmers who understood Joule's theory very, very well, when it came down to write programs, there was too much they had to unlearn. It was not teachable. And you take a look at these highly concurrent systems, you know, like the ones based on pi calculus, the Art chain system, and these things have an adoption barrier. Other people go to things like Haskell or other pure functional programming languages to get the formal properties. But take a look at the adoption, the adoption success that these languages have had in the world.
I agree with you, but I think that the real issue here is a cultural one. It is not possible to scale sequentially, and so what you'll have to do is you have to go around the generation of programmers that are no longer flexible, and start talking to the 17-year-olds who are on Twitch right now.
Are we tricking this?
No. So I think our general model of computation. So I did this massively concurrent language. One of the things that electric communities did is that they figured out how to get most of the benefit with islands of sequential programming. And now the general view of what large-scale distributed computation looks like is islands of simple sequential transactional programming in a sea of asynchronous communication. Now, you can make that island a Thailand lacter, but it turns out people have trouble with that. But, you know, in the JavaScript model, you know, it's the event-driven model, right? I've got my UI, event comes in, I figure out how to update the screen, and then I'm done and another event comes in. But while I'm updating the screen, it's kind of simple and sequential, and I understand that. You know, Node.js is, little transactions, and that model of potentially lots of concurrent activities, but they're all in isolated state communicating asynchronously with each other. That's a big part of our large-scale distributed model. And the nice thing is those might be on different machines. Those might be on different threads on the same machine. You know, they might be on different planets, whatever it is. It's just a matter of latency, how far apart they are. And so the thing that we've evolved to in JavaScript is, yep, it's got that simple loop at the top of the world, run something sequentially, and now you're done. But it's embedded in this asynchronous messaging world.
I'm so glad we're getting the different planets in here.
Absolutely.
Just to think about this.
We used to joke with your Xanadir about designing systems for, light speed where something was on Mars. And now we're dealing with blockchain where it takes just as long to execute.
Next meeting in our intelligence operation group will be space property divisions. Wait until next week. But I just want to say, now you make it out as those are nicely secured islands, but also the composability is a really big feature.
That's right.
So I just want to make sure that maybe it's the final thing before, we'll move into a more of a, communist space again, is really making sure that, we hit that layer of how is Agoric building really a future of a multiplicity of blockchains that are interoperable?
Yeah. Okay.
Go.
Okay. So I'll talk to those are both separate, but they're related. So React.js is a user interface framework and Vue.js, there's a few others like that came onto the scene for JavaScript, where suddenly now relatively inexperienced junior programmers could build amazing applications because they could grab components that were built by other people and plug them together. So it's a framework that had strong that in the framework addressed several of the hazards and problems people had doing user interfaces before, and enabled the plugging together of these components where it had affordances for what to do when a mouse clicks and how to do rendering and how to do styling. And as a result, it got literally exponential adoption of developers and literally exponential adoption or increase in what they could do, because the set of components they could plug together kept growing over time, right? Every month there was another 1,000 developers produced another 1,000 components that now I could use in my toolkit to make the next one, to the point where there's now more than 1 million components that people can put together into building user interfaces.
Wouldn't you even say that's what programming has become? It's no longer about language semantics and syntax. It's about class libraries and frameworks and
But
components.
it's not about class libraries. It's about components, and insist languages like Solidity, just like languages like C, you can't build components and you can compose the same way. And so the language is, the language is important up to the point where it gets you the ability to have components you can put together as sort of independent, isolated entities and plug them together with powerful
And
interfaces.
you secretly shared with me how much money is already being, or how much commerce is already being moved across change just today.
Oh, so now let's talk about, I'll get to that in just a moment here. So that's the component model that JavaScript has. We do the same thing for smart contracts, where instead of it being about mouse clicks, it's about exchange, it's about digital asset transfer, it's about claiming them, that sort of thing. We also worked with several people in the Cosmos ecosystem to do interchain protocols, where, as Mark said earlier, blockchain is just a machine built out of agreement rather than out of silicon. And all of our models of doing distributed computation with these islands of sequential programming, a blockchain is one of those things that can communicate asynchronously with another blockchain or with another machine or with my wallet on my phone or whatever it is. And so those protocols enable all of these, enable wide-scale distributed computation across blockchains. The IPC protocol that we came up, that we helped build, and that after we were already working on it, we found out months into that was inspired by the Elang site that several people here contributed to, and the overall model. But it deployed into production in the Cosmos ecosystem in April, I think it is, and blockchain deployed with it, where, unlike sort of the month before, now instead of each new blockchain, of which there are several, are deploying as these isolated islands, it was now deploying connected to literally tens of billions of dollars across other different systems. And so $10 million a day of collateral was moving across these IBC channels from other blockchains in order to support the applications that we're running on, in this case, the Osmosis system. So there have already been hundreds of billions of dollars transited across these interop protocols now, and it's only been since April. And that's really just the beginning.
So, and Archipelago now, so like very similar to how, I guess, much of the web that we know stuff.
Yeah, I mean, it's one of those things where it's subtle as people are starting to realize. It went from, 2 years ago, interoperability is crazy and composability, what's that? And now everyone tries to claim that they've got the most composability and everything's all connected, right? And they take interop for granted. It's like everyone's like, oh, my bridge is better than his bridge. And we've already got, $100 million on, total value locked on chains that we've connected to, and, stuff like that.
Yes, the way I explained it when we were founding Agoric and we were explaining this, the phrase that I used is, today, every blockchain, and back then it was true, every blockchain is built as if it is supposed to be the only blockchain in the world. And now, more recent blockchains understand that they're introducing a blockchain into an ecosystem of multiple blockchains, and they're trying to conceive of what they're doing, not starting from the premise of, well, what if we unilaterally took over the world? This is really quite related in philosophy to the whole unipolar versus multipolar AI. Do you try to build one single benevolent agent, or do you try to build an ecosystem with a diversity of agents that interact with each other in a loosely coupled and arm's length relationship?
It's actually even a little stronger than what you just said. Not only are the new blockchains thinking of themselves as connected, so the new blockchains are actually launching connected and leveraging it and using the heck out of it. But even for the old legacy blockchain of Ethereum, right? pretty much the sentiment is, a lot of money is moving off of that onto these side chains, onto secondary chains, onto, these chains connected with bridges, such that now even on the major chains, they don't think of themselves as the solution. They think of themselves as, as a whale in a large connected network. But pretty much everyone's on board with this, large scale connected world.
A whale in a large network.
Yeah, well, yeah.
Let's see whales. Okay, unless there's any other hands up, I want to make sure. Okay, yeah.
So do you imagine that you will completely supplant Ethereum, or will Ethereum still exist alongside?
I'm going to give a bit of a nuanced answer to that.
I'm watching them move everything.
Including Ethereum.
We are designing our system under the assumption that we're going to coexist well with many other systems. So we don't need to displace Ethereum in order to be a great success. If we do displace Ethereum, I won't be upset.
But, really, right now, blockchain is, hundreds of billions of dollars, but it's still a small pond, right? So, Ethereum is a big fish in that small pond, but mainstream use cases are much, much, much larger.
Yeah.
And so, we don't need to displace Ethereum to be bigger than it. We don't need to be bigger than it to be successful. I don't believe for an instant Ethereum is going to go away anytime soon, and it might evolve and change to accommodate the times. I mean, there's a lot of really smart people involved in that. It'll be around for quite a while.
Yeah. Also, open source software is free to recombine ideas. There's much less of a barrier against recombination of ideas as these things all grow. But the point about the world that's not blockchain is so much bigger. I want to stress that, which is we shouldn't be trying to, it's not like Ethereum and us are competing for the audience of people already into blockchain. Obviously, there's some of that. But the main thing is that we're competing to absorb the rest of the world that's not in blockchain yet.
Which is a million X larger.
Right.
Yeah, if you think about it, the vast majority of transactions crossing blockchains are all payments, essentially. But that's such a tiny sliver of what one tiny example, right? Imagine you had a music sharing service with 100 artists, each of which has 1 million followers and not too much overlap in those followers. Right? So that's 100 million people. Now let's say very conservatively, they listen to 10 songs a month. So that's very conservatively 1 billion transactions on that chain, right? So and that's one example. And by the way, that's orders of magnitude larger than what you see combined on Ethereum.
Yeah, it's just a lot of room. If we could just get chain of custody for freight onto a blockchain, decentralized distributed chain of custody would increase the global GDP by 5%. I mean, it's insane.
I guess it's like, getting back to the book, it's like competition in one area is also cooperation, for actually unlocking much, much larger areas.
Right.
Okay, maybe as final question is, if people are excited about it, what could they do to plug in more? Like, what's like a concrete, as we did with Peter, what's a concrete action item? Before we gave you probably lots of like things to nibble on as you ice break your way through the final conversations with each other.
Okay, we are headed towards mainnet. We're looking for developers to build stuff. So if you're a JavaScript developer, which if you're a developer, you're probably a JavaScript developer, then come build your application using the framework, using the platform, and be ready to launch when we do. That's one way.
Yeah, and mention the testnet.
We've had a long-running testnet that's been up and running and stable, and it's now connected with IBC to other people's testnets, and we're pretty central to a larger ecosystem of people doing decentralized computation. So there's a lot to leverage from that platform. The other way is, of course, stay involved with Foresight. One of the things that, we have a token. We've got, we'll have a chain that's launching with that token, and we expect to donate some of that token to Foresight, so they have a reason to keep paying attention to us. So.
We have it on record.
So, so there will be more initiatives happening out of this combined group to help make interesting stuff happen on Agoric specifically and blockchains in general.
Thank you. Anyone? Yeah. Chime in publicly. You have to find a word, Chris. Go for it.
What should I be building? Do you have like requests for proposals, or do you have like do you see what people are gonna have ready for mainnet? Like how many developers are building? Like if that is boring for a broader audience, I'm just like generally curious how this part of adoption is going and like what are thinking there.
So we're just starting the developer programs. We have bounty programs, which are specific things that we want someone to go build
on Gitcoin, right?
Yes, the bounties are on Gitcoin, or you can get to them from our site. But in general, those are if someone has an idea that they really want to pursue, we're interested in helping them pursue that. The thing that's sort of most interesting is something where the ability to rapidly evolve as you actually get into market and realize, oh, some of our customers want it to be a little bit different. So the fact that it's in JavaScript means I can quickly do that and deploy that. The fact that it's composition means I can reuse components and it's safe to rapidly put something out, whereas in Solidity, you should justifiably be terrified, right? And so applications like that are ones that will really leverage the platform. But so people are working on decentralized finance, people are working on NFT stuff, people are working on insurance, parametric insurance. So the answer is sort of, to me, as coming from a development background, I'm a lot more interested in what will be passionate to you that you'll really sink your teeth into and carry forward out to a real business.
Which part of the real world markets can you satisfy with the new technology?
Yes, which part of the real world markets can you satisfy with this new technology?
And then I just want to double check, Kate Sills, who is a Foresight fellow and also at Agoric, gave a fantastic talk on NFTs for property rights engineering. Really, really mind-boggling. And so I guess just as one of the example things of how you could be reimagining stuff.
Yep.
Okay. Any final words to the whole crowd before we disperse again into our decentralized little pods? Okay, then that was our final. Yes.
A lot of what we've been discussing is sort of incremental steps from the current world. So I want to just open it up to where this is going beyond these incremental steps. There have been throughout human history all sorts of people who've had ideas about, oh, if only society worked this other kind of way, or if only we could have a community that operated by these rules, or an organization of some sort. There have been all sorts of ideas, fantasies people have had about governance, and usually they're wrong. They will continue to usually be wrong because that's just the way experiments like this go. But historically, big governance experiments that went wrong were very, very expensive. In the 20th century, hundreds of millions of lives were lost in these experiments. We now have a voluntary medium in which we can create governance arrangements that people can join voluntarily and people can exit voluntarily, in which it's flexible and lightweight and has the unambiguity of program code. So Agoric, Chris Hibbert at Agoric just now completed the initial governance framework that we've got. He and Kate came up with this very nice, elegant sort of division of the overall problem of governance systems into sort of three independent dimensions they compose. It's really quite nice. So I think that if people, I think we, not just Agoric, I think in general with blockchain, but Agoric, I certainly welcome this, is we have this opportunity to experiment with governance arrangements. Most of these will go wrong. People will lose some money when these things go wrong, but these are experiments we can afford. And a few real innovations in governance of society that comes out of this rich experimentation can make all of our lives incredibly better. That's a very high leverage form of innovation.
Okay, you're here. So let's see what you guys come up with. Super excited to see it. Thank you so much for joining. Andrew, yes.
Is there a 30-second to 60-second statement of the Agoric governance structure? If not, it's fine.
Of the Agoric's governance structure?
Yeah. The thing you just described.
Chris, would you, I put you on the spot.
So the basic design is that there's a piece that I used to call a registrar that I'm being encouraged to call electorates instead, which is one software API that's about defining who has the ability to vote.
And our initial versions of that include one that's a committee, so some number of people have the right to vote, and it's visible who they are, and you can talk to the electorate to find out what questions they're voting on and what will happen as a result of that. Another one is people who own stakes in some token. Anyone who has one of those, some share of that, can vote, and they can vote by the weight that they carry. Orthogonal to that is a collection of different kinds of vote counters. The first one that I built just does binary questions. So, yes, no questions, or shall we meet at 10 or at 11. But the same architecture divides these two and makes it possible for another kind of vote to be electing a committee or choosing how much to raise a parameter by in a general way, or we can elect a parliament so multiple people have the ability to vote multiple times. So the division into electorates and vote counters, I think, makes a lot of things really clear.
And we have a quick summary.
Yeah, the particular thing of all the pieces that Chris went through is it's back to that composability point of view. It's composability of governance pieces, and that was one of the insights that Kate and Chris and I, and when we've talked about all of that really led to what's our governance going to be? Well, the governance is going to be a governance that will let us change our mind about that, and so we can do some experiments.
And again,
I'll say it this: if you can solve the problem of where a large group is going to go for dinner, it's Nobel Prize.
well, we're all gonna go here now from now on every night, guys. Don't you know? It's all gonna be here. No, but seriously, if you think it's right or wrong, I guess you just experiment and prove them right or wrong, or participate with them. That's the whole glory and beauty of it. Thank you so much for sticking it out with us. I can't wait. Oh, actually, maybe as a point of conversation starter, pick the thing that you most or least agree with what we just said, and find the person next to you and hash it out. And I will commit and listen to all of your fantastic conversations, because I feel like that's always really lost in these meetings. But I'm hoping that the more we meet, the more we can build actually just really free-flowing conversations amongst all of us. I haven't seen you guys in so long since the pandemic. I'm really glad that I finally do. Very touched, actually. And yeah, I'm hoping to see you all on Zoom again, or then maybe at our member gathering, which is December 4 and 5 in San Francisco, and December 11 and 12 in France, and between that in the cyber layer. But yeah, I'm hoping this is not the last one in between. If you want to do stuff with us, let us know. And thanks so much for hosting us again. And yeah, can't wait to chat with you for the final, remaining 30 minutes or so. So have another drink, and I'll see you, at 2 meters down the line.